Right. You are once again welcome to More Connect. Okay. So today we are going to deal with one of the most topic that is mostly not taught at the senior high, but it is in our textbooks. Okay. Yes. And that is logic gate, or we say logic circuit. So it is logic gate or logic circuit. Logic gate is simply electronic circuit which are arranged. Okay. They are mostly found within appliance. Okay, so when I talk about appliance, the gadgets that we have around our motors, we have our fridges and all that, blenders, they all use logic gates. Okay, these gates are just electronic circuits. Okay, that are put together so that these appliance, so they are being put together so that this appliance can bring about decisions. Okay, so it enables the appliance to make decisions. Okay, and then to enable them to process commands. Yes, so we have electric fans in our various homes. Okay, so when you have this fan which has not been plugged, okay, it doesn't work. But the moment you put it in a plug and you switch it on, it doesn't work as well unless you turn the buttons that are found on the fan before it starts spinning or rotating. So this means that there are series of connections that are made. Okay, there are series of what connections that are made to bring about this appliance processing your command, and that is logic gate or circuit. Yes. Now, what is responsible for this activity is the three pin component which we call transistor. Okay, so here we say it is electrical transistor where these transistors are made to behave as switches. Okay, we all know the symbol for switches in physics, electrical components. Okay, so these transistors are designed to behave, not to behave, but to work as switches. And we know for switches, they are either open like this or they are closed like that. Where we have the generator. So they are either closed or open. Yes. So we have switches which are open, that is current do not flow because of this opening. But here we have this opening close here and close there, so current can flow. So this makes this one on and this makes this off. Okay, so in logic gate, we say these transistors make the activity possible because the moment you plug the fan into the socket, you on the socket, then you will come and on something on the fan itself before it start working. So it means there should be something that we call agreement. Yes. So logic gate or circuit should agree with each other to perform or to process a command. So in the case where one do not agree, we have the opposite of what should have happened. Okay, we would have the opposite of what should have happened, and that also will lead to a different way of getting into logic gate. Now, they are mostly logic gates are mostly represented with, yes, they are mostly represented with truth table. Okay, truth table. So this table describes the behavior of the possible outcomes of the logic gate. So we will just delve into the forms of the logic gate, but before we get to that level, let's get ourselves acquainted with styles here. So a table that will surely describe the behavior of all the possible outcomes of this gate we are talking about. Okay, or the logic circuit. Now don't forget there's an arrangement of transistors in there which behave as what? Switches. And this truth table that we are talking about involves the use of binary numbers or digits. And we know from binary means two. Okay, in biology we say or in chemistry, binary compounds. They are compounds with what? Two elements. So here we have a binary, which means two. So in this regard, the two that we are talking about is 0 and 1. Okay, 0 and 1 are the binary digits we are going to use in this topic. Now, this topic is mostly not taught. I've said this earlier because WAEC has, I don't really know, but they have stopped asking questions on that. But NOVDEC students in other courses, yes, you should take advantage of this, and even WASI students too should take advantage of this. We are all taking advantage of everything. So in case it drops, we would better know our way out. Now, let's get into it. So these numbers are 0 and 1 for binary numbers. Okay, for binary numbers. Yes, so let's go into the forms of logic gate. So we have the AND gate, we have the OR gate, we have the NOT gate, we have the NAND gate, then we have NOR gate, then we have, so we have AND gate, OR gate, NOT gate, NAND gate, and then NOR gate. There are others that we will come up with in the next video. So we also have XOR gate and all that, but we will come back with it some other time. Now we have the first one being AND gate here. So AND gates are mostly found within appliances, okay, where all inputs supposed to be positive to give a positive result. Now let me explain that here. And one thing that you should know is that all logic gates or logic circuits, their forms have electronic symbols. Okay, as we have diode having electronic symbol, we also have logic gate having electronic symbol. So we know diode has it, inductor has a symbol, resistor has a symbol. Okay, so resistor symbol, something like that. Yes, something like that for resistor. And then we also have other components, switches, they all have their symbols. So in the case of logic gate, there's also symbols for all of them. So today we are going to deal with the first two. Yes, so today we're going to deal with the first two, which is AND gate and OR gate. Okay. Now, one thing about all forms of logic gate is that we can represent them with truth table. I told you the table that describes the behavior of all the possible outcomes. Okay. And don't forget, these possible outcomes are in the form of binary digit. So let's see how we can go far with AND gate and OR gate. So for AND gate, we have the symbol to be like that. Yes. So this is the symbol for AND gate. Okay, then we have the output. Sorry, let me add the output. Yes. So mostly for senior high level, we have this side is the input. Okay, this side is the input, and this side is the output. Okay, so for AND gate, we have its own characteristics. AND gate has its own characteristics, which is different from OR gate, different for the rest of the other gates. Now, so let's consider the AND gate first. This is input 1, this place is input 2, and this place is output. For every activity, you will have an output here, and you will have the input here. And these inputs are the binary digits, which is 0 or 1. Don't forget, 0 or 1. So we can have 4 series of these values. Okay, we can have 4 series of these values. Now, if here is a the input 1, so let me make it 1 so that we go faster. So input 1, so this is 1, input 1, and this is input 2, and then we have output, say B. Okay, so this is output B. Now we can have the truth table in this form. So we have 1 here, 1 here, then 2 here, then we have our B here. So this is AND gate. Then we have these lines here, then we have our lines here. I'm sorry. Then we have one of the lines here. I even drew the same thing. Let's continue with that. Yes, then we have this here. So this is the truth table. This is how we represent it. So this is for AND gate. Now let's see. So one, I think I can let me make here A. A, okay. A will be better. A will be better. So A and then 2, and I have B here. So A will be better because I'll be using numbers down here. So I have another A here. Yes. So let's see how we could find out. Now, the binary numbers are 0 and 1. Okay. But here, at this level, we are going to consider twice of these numbers. Twice of these numbers. So we're going to consider 0, 1, and then another 0, 1. So it could be 1, 0, it could be 1, 1, or 0, 1, something. So let's see. So 0, 1, 0, 1. So in the case where I have this 0, so this is one input. So imagine this is connected to a speaker and this is connected to a mouse. Okay, but we are dealing with numbers, digits, so that we later apply this in the real world. Now, so imagine A is 0, or A is 1, or A is still 0, or A is still 1. What will be the corresponding values here? It could be that this 2 here could be 0, this 2 here could be 1, this 2 here could be 0, this 2 here could be 1. so that we will have the output of both. So let's see, A could be 0, A could be 1. So there are four possible ways. Then we still have another 0, then we can still have another 1 here. Yes, so let's see how it works. So this is the truth table for AND gate. Now, if A is 0, Z can also be 0. You can have 0 here. Z can also be 1. Z can still be 0. Okay, sorry. So we can still have 0 here. Then we can have Z to be 1. It doesn't mean it is always this way. This is just an example. Okay, we can have here to be 1, 1, 1, 1, and then 0, 1, 0, 1. You just don't have to go beyond 1 because it is binary. Yes, so let's see how the AND gate works. So this is how the AND gate works. Now, before you get a positive output, A and Z supposed to be positive. If 1 is 0, then the output is 0. Please let's pay attention. So when they ask you what is an AND gate, AND gate is a form of, or we say a type of logic gate where the positive input gives a positive output. So we could have A being 1, 1 means positive, and then Z being 1. So both are positive. Then we have a positive answer here. Otherwise, here becomes 0. So let's see. A is 0, Z is 0. It means that from the definition, we will have here to be what? 0. Okay. So if A is 1, A is 1 and Z is 1, we will have output to be 1. And then if both are 0, we still have 0. And if both are 1, we have 1 here. So let's go with another example. They say A, then we have Z here, and then we have our B here. So imagine this time we have 1, 1. Okay, let me separate it a little. So imagine this time we have 1. Okay, let me get this one here. 1, 0, then say 1. Then let's say we have Z to be 0, 1, 1, 0. Now for AND gate, these two input here should be 1, 1 for us to get 1 here. Otherwise, here is 0. So the otherwise means that the moment 1 changes from the 1, you get 0 here. So we would have 1 and 0, which is 0 at B. So 1, 1. It means both inputs are positive. So we would have a positive answer at B. which is 1. 1 is 0 over here, so we still have our 0, and then we still have our 0. Okay, so this is how the AND gate works. So let's consider a situation where we have three inputs. Okay. Situation where we have three inputs. Okay, so a situation where we have three inputs, where we have a third one here being maybe C. Okay, so we would have A, we will have our A, then we have our Z, then we have our C. Okay, so and then we have our B, because B is the output. So most boosts will give you this here. Most boosts will give you this, but it's the same thing. Okay, you have this in the truth table, where here becomes input and here becomes output. Okay, yes, so this is three input. Now from the definition, it means all these three here supposed to be 1. So we say positive. So they are all supposed to be positive before we would get a positive answer at B. So imagine I have this 1. So I told you we are dealing with 4. Okay. So it could be 1, 1, 1, 0. Then say 1, 0, 1, 0. Then say 1, 1, 0, 1. So the output would be 1 for the first one. Since there's a 0 here, we'll get 0 here. Because the definition says that all this for AND gate, all this should be positive before we get a positive answer. So the moment 1 is 0, we get 0. So here 1 is 0 in the input, we still have our 0. And then 2 of them is 0 here, we have our 0. Even if the inputs are 10 and 1 of them is 0, you have the output what? 0. This is for AND gate. Okay, so let's go to the OR gate. Let's go to the OR gate. So let's go to the OR gate. The same procedure. Oh, so this is the OR gate. All right. So the OR gate also has its own symbol, as we saw for the AND gate. The input depends, okay, but just work with the principle. If the principle for AND gate is that if all the inputs are 1 or positives, you have a positive answer. Otherwise, you have 0. So let's look at OR gate. The symbol for OR gate is also like that. Yes, so the symbol for OR gate is like that. They would have this. Yes. So these are the input, and we have our output here. Okay. So the same format, 0, 1, binary, another 0, 1. So we're working on these binary numbers. Yeah. So let's see how a truth gate works. Now, the principle for OR gate is that if any one of the input, if any of the input is 1, we have a positive output. So if any of the input is 1, we would have a positive output. So for logic circuit or logic gate, this 1 means that the thing is on, and this 0 means that it is off. So you will hardly hear on and off, but you will see 0 and 1, where 0 represents that the thing is off and a 1 represents on. So the same format, we have A for the first line as in the first input of the OR gate. This one is A, and what is here is B. Okay. Oh, sorry. My pointer is misbehaving. So we would have the second part to be B. Okay, this is B, and then we will have here to be C. I know most of you read the textbooks and you still don't understand the OR gate and the logic gate, but I want to break it down for you to understand it better. So we would have our A here. I told you here will be input, and this big line coming here will tell us the output C. That we would have the second input B. Okay. So most people should say input and output, but this is the same thing. So let's see. So if I have 1 here, 1 here, 0 here, and then another 1 here, this means that okay, then before we conclude, let's get to B, where we can have say 0 here and have 1 here and have 0 here, and then we can have another 0 here. So we have two ways of writing the output. Now, the definition is that if one of them is positive, we will have a positive answer here. If both of them are positives, we will still have a positive answer here. So it means that the OR gate can still function as an AND gate. Okay, so it means that the only consideration is that at least one supposed to be positive. Now remember that from AND gate, both it is a straight rule that for AND gate both should be positive so that we get an output. Okay, but for OR gate at least one should be positive. So if both are positive, we still have a positive answer. So for this example, 1 and 0, we will have the answer to be 1. Okay, 1, 1, we still have the answer to be what? 1. 0, 0, as usual, 0. 1, 0, we still have 1. At least one supposed to be, sorry, at least one of the inputs supposed to be what? 1. So it could be 1, 1, 0, 1, 1, 0, every other way. Okay. Yes, so let's end here, and then the next video we continue with the other logic gate. Don't forget to subscribe to the channel, and we'll get you more videos on your studies. Goodbye.